The James Webb telescope has detected signs of life on a distant planet. You've probably heard about this. It sounds impressive, but let's figure out what's real science here and what's just a flashy headline. By the way, I stepped outside under the starry sky for a reason. Today, using this amateur telescope, we're going to find in the sky the very star around which the planet called K2-18b orbits. It's in this planet's atmosphere that scientists have found biomarkers. On my channel, we do practical astronomy, so together we can get a real taste of big science. I'll even try to spot the James Webb telescope itself. Let's see how it's doing right now, and at the same time we'll talk about 5 truly significant, rather than just viral, discoveries it has made. Let's get started. So what exactly is K2-18b? It sounds like a random jumble of letters and numbers, like one of those CAPTCHAs to prove you're not a robot. But no, there's actually a clear logic to it. K2 is the designation for the second mission of the Kepler Space Telescope. After 2 of its gyroscopes failed in 2013, the original Kepler mission was modified and the K2 program began. Essentially, it was a continuation of the search for exoplanets, but now using a different stabilization method. And 18 is simply the serial number. K2-18 is the 18th candidate star where the existence of exoplanets was suspected. And at this point, the presence of 2 has been confirmed, K2-18b and K2-18c. And the first of them became a superstar in recent news because there is evidence suggesting the possibility of hypothetical life there. But when you read these articles and see those letter and number designations, you kind of perceive this news as something out of science fiction. After all, it's somewhere far away and not related to us. But in reality, you can actually photograph the star K2-18 with an amateur telescope. It's located in the constellation Leo, and the constellation Leo is right behind me. Isn't that a good reason to try to find it and take a picture? The star K2-18 is located on the border between the constellations Virgo and Leo. This is what the constellation Virgo looks like. It's adorned by the fairly bright star Spica. The constellation Leo is located nearby as well. That's exactly where K2-18 is found, though it's outside the famous shape of the constellation. Roughly right here, you can see the exact coordinates on the screen. For the filming, I used a Skywatcher 130 PDS telescope on an HEC5 Pro mount and a ZWO-294MC Pro camera. After stacking 21-minute frames, I got this result. Take a look at this ordinary-looking star at first glance. In front of us is the red dwarf K2-18 with a magnitude of about 13.5. For visual observations, the object is quite faint. You'll need a large amateur telescope to see it, but as you can see, it's quite possible to capture it in a photo with some skill. K2-18 is located 120 light-years away from us. It is twice as small and cooler than our Sun. As I already mentioned, 2 exoplanets have been discovered around this star so far, but it's K2-18b that has attracted the most scientific interest. It was discovered by the Kepler telescope in 2015. Initial measurements showed that it is likely located in the habitable zone, meaning an area where the temperature is suitable for maintaining liquid water, and that's a marker for possible life. Already in 2019, thanks to data from the Hubble Space Telescope, water vapor was detected on K2-18b. By the way, the Hubble telescope was launched into orbit in April 1990, and now we're celebrating the 35th anniversary of its scientific work. Hubble's orbit is at an altitude of about 545 kilometers. Unfortunately, in the northern regions, it's impossible to see it pass by. Even for me at the 43rd latitude, it doesn't rise higher than 10 degrees above the horizon and is only visible for a few days each month. These are rare shots for me. So far, I've only managed to capture Hubble passing by once. That barely visible dot flying along the edge of the field of view is the legendary orbital observatory. Hubble's brightness here is only about third magnitude. At that altitude and in these weather conditions, you can only spot it with binoculars. For me, watching Hubble fly by is a kind of tribute to its outstanding achievements. And at the end of December 2021, a new chapter in astronomy began. The James Webb Infrared Telescope was launched into space. From a layperson's perspective, it became a kind of successor or replacement for the Hubble Observatory. That's why they are often compared and talked about together as a pair. There's even a special service called Space Telescope Live, where you can see what the Hubble telescope is currently observing and what the James Webb is looking at. I'll leave a link to the website in the description. Go check it out and get mesmerized. The connection between the two space telescopes is also confirmed by the fact that the James Webb observed that very exoplanet K2-18b shortly after it began operations. The first wave of excitement happened in 2023 when, after James Webb's observations in the near-infrared range, scientists detected molecules of methane, carbon dioxide, and signs of a compound called dimethyl sulfide on the exoplanet. This is a strong biomarker. On Earth, it forms in the oceans and is released by phytoplankton. However, the initial observations were not accurate enough. And now, the James Webb Telescope has conducted additional studies of the planet K2-18b using another instrument in the mid-infrared range. Once again, it found traces of dimethyl sulfide. And now, with 99.7% certainty, scientists can say that this is not a statistical error. After all these discoveries, we now have a more complete understanding of the planet K2-18b. Initially, it was considered a super-Earth with a rocky surface. But now, scientists believe that what we have here is a sub-Neptune or a giant, meaning an ocean planet with a hydrogen atmosphere. The presence of dimethyl sulfide could indicate that the ocean on K2-18b might be teeming with living microorganisms. But for now, we can't talk about any real discovery of life on the planet. This is just a hypothesis. There are several problems with confirming it. First, dimethyl sulfide might not be related to biological activity, and finding inorganic sources for its synthesis is an interesting challenge for astrochemists. Second, further research is needed to improve the accuracy of the data obtained. Studying the spectrum of exoplanets is an extremely complex and non-trivial task. But just think about it, what a giant leap forward science has made. The first exoplanets were discovered in 1992, right when the Hubble Space Telescope had just started operating. Now we're already studying their composition. This isn't science fiction, it's reality. We're already getting images of planets around other stars. At the Keck Observatory, after several years of observing the HR 8799 system, they captured their planet's movement. And here are those exoplanets in a James Webb photo. The next big discovery in exoplanets might happen in the TRAPPIST-1 system. There, 3 planets are in the habitable zone, and the James Webb is already observing them. So, we're waiting. Actually, when we talk about the connection between the Hubble and James Webb telescopes, we should also point out the major differences between them. Hubble's mirror is 2.4 meters in diameter, while Webb's is already 6.5 meters. Hubble mainly observes in the optical and ultraviolet ranges, while Webb operates in the infrared. That's why it can delve deeper, look farther, and get closer to the moment of the Big Bang. And their orbits are also very different. As I mentioned earlier, Hubble orbits the Earth at an altitude of about 545 kilometers, while James Webb is located at the Lagrange point L2. To spot it in the sky, we'll need a telescope, an astrocamera, and precise coordinates. We can get those coordinates from NASA's Horizons website. Here we find the Webb telescope, enter the required dates and intervals, and generate the ephemerides. Now we can upload them into a planetarium software to find out where the spacecraft is currently located in the night sky. I use the planetarium software Stellarium, and as we can see right now, James Webb is in the constellation Scorpius. Yeah, it's probably interesting to see in Stellarium where the James Webb Space Observatory is right now, but it's way cooler to do this under the real night sky, especially since the constellation Scorpius has already risen pretty high above the horizon. There it is, right behind me. By the way, the bright star you can see there is Antares. It really adds a special touch to the constellation. Unfortunately, in the northern regions, Scorpius doesn't rise very high, so capturing James Webb these days will probably be tricky up there. But here in the south, I won't have any trouble with that. So very soon I'll be pointing my telescope towards the constellation Scorpius. And forgive me for this cliché, but I'll try to capture it with my amateur telescope, a space telescope, that is. But for now, let me try to use this laser pointer to show you where James Webb is hiding in the constellation Scorpius. And I'll do this under the real night sky. So here we have the Scorpion's claw. The constellation is adorned by the red supergiant Antares, and somewhere in this part of the constellation, the James Webb is hiding at the time of filming. Well, from here on, it's all about technique and experience. I aimed at the right area of the sky and checked if the mount was on target. To do this, I compared the image obtained by the camera with a pre-prepared map. Once I made sure everything was set, I started shooting 60 frames, each with a 1-minute exposure. Then I stacked every 10 frames together and ended up with this animation made from 6 photos. And honestly, at first, I thought I had failed. That's how faint and unimpressive the James Webb turned out to be. And only after looking very closely was I able to spot it. That faint moving dot is the very same now legendary space telescope. Well, hello, James. We haven't seen each other in 3 years. How time flies. We've figured out the exoplanets, then let's see what else interesting James Webb is up to. Let's start with a record. The telescope outdid itself by discovering the oldest galaxy to date with this name. I will never reproduce it myself. It formed just 290 million years after the Big Bang. To put it in perspective, if the history of the universe were a single day, we're seeing this galaxy in the very first hour after midnight. Initially, the object was spotted using the NIRCam near-infrared camera. It turned out to be too bright for its age, which made scientists suspicious. But at the beginning of 2024, the results from near-spec spectroscopy came in, and everything was confirmed. The redshift Z is 1432, which means the wavelength has been stretched by a factor of 1532. This is a new absolute record and gives us even more to think about. For now, it's completely unclear how the first galaxies and black holes could have formed so quickly after the Big Bang. James Webb has also made an important clarification regarding the rate at which the universe is expanding. We've had a problem for a long time. If you calculate it based on the cosmic microwave background, you get 67 kilometers per second per megaparsec. If you measure it using today's methods by observing unique beacons in the universe like Cepheids and type Ia supernovae, you get 73 to 74 kilometers per second. Now, Webb has measured a distant supernova and actually observed it 3 times thanks to gravitational lensing. Yes, that's right, the same explosion in 3 different versions and got 75.4 kilometers per second per megaparsec. So, the discrepancy has been confirmed. Cosmologists are now even more puzzled. But James Webb isn't just studying the far edges of the universe. He's also making discoveries right here in the solar system. For example, Webb was the first to observe auroras on Neptune. It had long been suspected that they existed, but now we have confirmation. And everything about this is unusual. The auroras aren't at the poles like on Earth or Jupiter, but at mid-latitudes. It's all because Neptune's magnetic field is tilted sharply by as much as 47 degrees relative to its axis of rotation. And since we're talking about auroras, I just have to share something with you. On the night of May 2nd, I teleported from the 43rd to the 59th latitude and captured this kind of beauty. I hadn't seen green auroras for almost 3 years. It was a real pleasure to see them again. Finally, Webb has recorded a record-breaking plume of water erupting from beneath the surface of Saturn's moon Enceladus. The The plume stretches about 9,600 kilometers. That's 20 times the diameter of Enceladus itself. At the same time, the volume of the eruption is 300 liters per second. Interestingly, only a third of the ejected water stays with Enceladus, while the rest disperses and replenishes Saturn's rings. Enceladus is actually one of the most intriguing candidates for the existence of life in our solar system. Beneath its icy crust lies an ocean of salty water, and now we know it's much more active than previously thought. You have to admit, these are some fascinating discoveries. It's simply impossible to cover everything in just one video, and I hope that for James Webb, this is only the beginning of a long and glorious journey, just like Hubble's. Once again, it's hard not to make these comparisons. And with that, friends, that's all I have for today. If you enjoyed it, please like, subscribe to the channel, and leave as many comments as you can. Clear skies, successful observations, and brilliant discoveries just like James Webb.